Okay, so we look into this question. Let me give you a clear, you know, view. So the question reads as: a train of 300 meters is traveling with a speed of 45 kilometers per hour when it passes a point A completely. At the same time, at the same time, a motorbike starts from point A with a speed of 70 kilometers per hour. When it reaches exactly the middle point of the train increases its speed to 60 kilometers per hour, and the motorbike reduces its speed to 65 kilometers per hour. How much distance will the motorbike travel while passing the train completely? Now, if I have to make a, let's say, schematic, although it's not required, suppose this is the train, okay, which is 300 meters long, and it is traveling at the speed of 45 kilometers per hour. Okay, and there is a motorcycle, and this is that point A. There is a motorcycle which is going at a speed of 70 kilometers per hour. Okay, 70 kilometers per hour. Now see, the point that I'm trying to say is that exactly at the middle portion of the train, which is, at a distance of 150 kilometers, there's a different story which is, happening. So till the midpoint of the train, or the middle section of the train, everything is picture perfect. There's a relative speed also. Relative speed is 70 minus 45. Okay, 70 minus 30 is 20, so 40 is 30 minus 5 is 25. Okay, so 25 kilometers per hour. This is the relative speed. Okay, this is the relative speed. Now 150 meters. Okay, you have to remember this thing. This is 150 meters. So time to meet, in other words, because both of them are traveling at the same time, okay, both of them are traveling at the same time, and it is also written that up till that point the speeds are exactly the same, so we can use the concept of relative speed. And relative speed says, because they're in the same direction, they're moving in the same direction, what I can say is time taken to meet will be 150 multiplied by 25 into 5 by 18. Okay, this is 150 into 18 by 25 into 5. I'm not going to do anything. Now this is the time taken by the motorcycle to surpass the gap that is created for the motorcycle till the midpoint of the train. This is the time to overcome that, that gap. Now, because this is the time, if I multiply the speed of the motorcycle, which is 70 kilometers per hour, into 5 by 18, that converts this entirely into meter per second. Okay, this is the time taken in the first part. Okay, I hope this is clear. I will not simplify this. Okay, there's no need to simplify, or if you want to, you can also, because I can see a 5 and a 25. I can also see a 5 and a 30. 5 3 is a 15, 0. 5 6 is a 30. 18 and 18 also cancels out, and this is 6 7 is a 42. So 420. This is the distance. Okay, so I hope this is fine. Distance is equal to time into speed. This is the time. So exactly how much time, how much distance, this is the relative distance. You can, in other words, you can also say this is the relative distance. Now we'll have to calculate for the part B of this problem. So, and the part B is same thing, 150 meters is same, because so far 150 meters pe ja karke this becomes 60. So one of the speeds of the train becomes 60, and the other one reduces from 70 to 65, so which is 65. So relative speed will be 5 kilometers per hour. Okay, ignoring the negative sign and all, so 5 kilometers per hour, which is 5 into 5 by 18. This is the time taken to meet. Time taken to fill the gap. Okay, this is the time taken to fill the gap. So 150 into 18 by 5 into 5. Multiply this with the speed, which is 65. This is speed of the motorcycle. 65 into 5 by 18. Five and 5 cancel. This cuts it with a 13. And a 13 and a 15 is... Let me do this. So... Okay, so something that I could have done in my mind also, but I just wanted to be sure. So 1950 meters is the distance. This time the motorcycle will have to cover. So when you add this 1950 to 420, you will get 2370 meters, or divide this by 1000, 2.37 kilometer. So how much distance will the motorcycle travel while passing the train? So this is this much of the distance. Okay, 2.37 kilometers. Thank you.